what is risk analysis to start with? I wish there were a simple answer to that question. So if we look in the back, historical, one could basically say that risk analysis is about asking how likely is it that something very bad will happen. And then we can sort of divide these questions into what could happen, how likely is it, and what are the consequences. And then we can put together a group of experts, like this chart, this risk matrix to the right here, where we have experts from all the world assessing the likelihood and consequences of various hazards that they have identified. Well, this is like the old version of risk analysis, I would say, because something has happened. When we started to do risk analysis way back, we had kind of simple questions. They were focusing on one type of hazard. Today we have to combine hazards. We also have the problem of having a large amount of uncertainty. Basically, the low-hanging fruits have been picked. Now we're working with more problematic problems, so to say. So lately, a fourth question have arisen, like how strong is the knowledge basis for our answers to these questions? And basically, one can think of risk analysis as a scientific discipline of assessing, understanding, and managing risk. So it's not just about answering these questions. It's also about putting it in a context, like if we're going to manage risks, how do people perceive them? What is a good way to manage it? And what is a good way to assess it? Because that's not always clear since we have already picked the low-hanging fruits. So we have a lot of sources of uncertainty coming into when we do risk analysis. So we have this girl, she's walking, she's taking a risk. It's voluntarily, it seems like it's like that here. So we have risks that are good and we have risks that are bad. We have uncertainty about random outcomes, like flipping a coin. We have something black swans, things that we don't know. And then some things are really difficult to understand. Maybe we lack some parts of knowledge and we don't really know how to do it. Then we have these extreme events or surprises. I personally like to be surprised, but if it's something good, that is. There could also be very bad surprises around. So we want to avoid the bad surprises. We want to keep the good surprises. We want to be able to do innovations, although there may be large sources of uncertainty to it. So this is a very famous quote, and I would say that what Donald Rumsfeld is saying, it has been on the table before that, but since it's a very common quote summarizing these parts of uncertainty that we actually have to consider when we do risk analysis, I put it up here. And basically it is that risk and uncertainty are two things that are intrinsically related to each other. Basically, I would say that risk analysis is an assessment of what could happen when there is uncertainty. And I don't specify a specific type of uncertainty here. I'm just saying that it's something that we do when there is uncertainty around. And we need to sort of assess what could happen and so on. This is seen, for example, in the latest ISO definition of risk. I know this could be a bit boring to present ISO definitions, but it's quite interesting to look at this because when you talk to someone, they say risk is likelihood times consequence. No, it's not the case. Not even if you look at this definition, which is supposed to sort of have a huge impact of how risk is seen and perceived in the world. And this is basically the result of experts getting together, reaching a consensus of how to define things to make things a world a better place. What is this? Well, risk is then the effect of uncertainty objectives. That's all. And if you look at this definition, you sort of scratch your heads. What did I mean by effect? And what are these objectives? And basically it means that we have some kind of decision objectives. We're going to make a decision, and then risk is about understanding what impact does sources of uncertainty have to the outcome of our decisions. In order to agree, you have to make some kind of notes here. So they explain what an effect is, and they also say that the effect could be both negative and bad. So basically, since risks are more complex today, we're not only looking at bad things happening. We are looking at, because something can be bad for someone and good for another one. So we're looking at what could happen in general. And then we also see that these decision objectives, they could sort of be very smaller or larger, or it depends on the context what is meant by these objectives. And then, of course, it's usually expressed in terms of potential events, consequences, and likelihood. Right. When we do assessments of risk, and this is an example from an output from an assessment done by the European Food Safety Authority, where they looked at the dioxins and related PCBs and tolerable limits. And basically this was done 2018, I think. And the results from this was that they changed the tolerable weekly intake for dioxins and related PCBs. And this is the result of a scientific assessment where they sort of iteratively redo the assessment. They take new evidence into account, and then they revise the recommendations. And from a social science perspective, it could be weird, but you just said it was okay and now it's not okay anymore, and so on. So one has to understand in risk analysis, what are the consequences, how do people understand this, and how can we make them to make good decisions. And it's also interesting to note that this is the recommendations to not eat, but then whenever we do come with recommendations in the daily life, we have to consider other things. So for example, we have surströmming, the Swedish dish, which is full of these dioxins. They are poisonous, basically, according to these tolerable weekly intakes coming from this scientific assessment. But still, we eat them, and we allow them to be eaten, but only in Sweden, because we have cultural values that are important as well. So basically, we weigh scientific assessment of risk to other values and concerns. They're poisonous if you eat a lot. Right.
Because of the dioxins.
Okay, we can discuss that. So basically, when we are doing a scientific assessment of risk, which was what the European Food Safety Authority had done in this case, we can think of that this is science, where we have a nice and tidy room. It doesn't look like this in my home, I can tell you that. And this could be when we do scientific assessments. It's messy. We don't have complete information. We are not able to do the studies ourselves always. We have to use second order material. We have to come up with an answer even though we want it or not, etc., etc. And in all these things, we have to sort of be aware that when we are moving from science to scientific assessments, we take into account more types of evidence. We are relying to a large extent of modeling and theoretical aspects because we want to predict things that could happen in the future which we haven't seen yet under different situations that hasn't occurred yet. And we have to rely on expert knowledge to a large extent than done in science. So basically, when you move from doing traditional science to you do scientific assessments, you need to be able to move in these tidy and messy rooms. I'm not saying that all scientific assessments are in tidy rooms. Another thing is that we can think of that, okay, the evidence basis to come up with some recommendations, they are usually very strong in the tidy rooms and they are very weak in the scientific or in the messy rooms. I think that this idea of evidence as being very strongly connected to the sources of information you have available, that is creating a problem. Because as I said, these are the easy ones to the left, while the actual answers that we have to produce are often in the messy room. And the key to all of these things is to improve how we treat uncertainty. So, I will come back to that, and I will just talk about evidence-based decision-making for some while. There are several collaborations or organizations working with evidence-based decision-making. Here are some of them, and they are usually independent. They are financed by, not by the they have like several people supporting them with financiation. Some of them are getting finance from governments. We have, for example, the Swedish Agency for Health Technology. We have In the UK, we have the Department for Environmental and Food Rural Affairs. If you go into these organizations or authorities, you see that they have very explicit guidelines for evidence-based, how to produce scientific assessments, and they're working on improving them. And I will come back to EFSA at some point. So, for example, we have the Collaboration for Environmental Evidence, and they are focusing on producing evidence-based or systematic reviews in the field of environmental science. And the Swedish partner for that has been the MISTRA EVM, and recently this has moved over to FORMAS. So FORMAS are now doing like financing systematic reviews or synthesis, they call it, as part of this. And I can see that there is a whole flora of different organizations or authorities having the ambition to produce support for evidence-based decision making. And if I look at the guidances from these organizations, they differ a lot in how they actually work with the messy room type of problems. So if we look at these two things, first we have risk and then we have evidence. So before it was that sometimes you said we're going to have a risk-based decision making. We're going to be, if risk is high, we have to deal with it, and we're going to follow what's coming out from risk assessments. And then we have these evidence-based decision making policies, which says that we should make decisions that are based on evidence, and that in a sense limiting to having you can only make these decisions when there is good enough evidence available. And risk-based means that you're looking at extreme events, you're looking at bad things happening, and you want to be sure that you can treat these. Then there's been a discussion that, okay, maybe we have to take other things into account, like the surströmming and other things, cultural values. We can't just focus only on risk, and then you say instead risk-informed, right? So you have risk-informed decision-making. At some point, you're saying, well, we can't just sort of guess what the risk is. We should make the risk assessment based on evidence. We should use the evidence out there. We should have a systematic approach of using evidence. So then the idea is that decision making should be evidence-based and risk-informed. And I say that some organizations are here now at this point where they say that we have to have really good evidence, and we have to look at all possible things, extreme events and bad things happening, and pay attention to that. We can't just look at what happens in average. We have to look at the extremes as well. Well, this is not the end. Because, as I said, the Donald Rumsfeld citation and so on, uncertainty is an important part when we deal with decision making. So basically what I say that we want our decisions to be robust to uncertainty. And this means that we want it to be not sensitive to, we want it to be a good decision although there are uncertainty. The marriage of these two things is then evidence-informed, because let's inform it, risk-informed and robust to uncertainty. That's the type of decision-making policies that we should aim for in the future. And I see some organizations are adopting this uncertainty discipline. For example, the climate change reports, they have developed a lot of principles and guidance on how to treat uncertainty, because uncertainty became an important part in their reports, and they saw that people reacted to how they presented uncertainty, and if there were uncertainty they should expose it and don't hide it, because that was an important role on how the report was used or taken into account when it came out. So I don't know where you are in this map, but I think that I hope, let's not complicate the last one too much and work for that for a while, the coming 10 years or something. So, uncertainty. How should we express and communicate uncertainty in scientific assessments? This is a question I've been asking myself for a lot lately. And I'm going to give some thoughts about that. First of all, let's start with the communication part. At the end, we know that decision makers, there is uncertainty. They have to understand it's uncertainty in both facts and values. And if they don't understand the uncertainty involved, they could put too much confidence in an assessment or experts, or they can put too little confidence in experts and the report. So no matter what we do, it's going to be wrong, I guess. But what should we do? The alternative, I mean, I don't personally believe when people say that decision makers don't want uncertainty. They don't know how to treat it. They just want a plain answer. I personally don't think that's a way to sort of say that, okay, let's not treat uncertainty because they don't want it anyway. I think they want it, and we should educate them to want it. So basically, when we communicate, we can have different goals of communication. We can try to persuade them to do certain things. We can say that if we decide to say there is uncertainty and that will maybe change their behavior, well then if we don't want them to change it in a certain way, maybe we should disguise uncertainty. And if we want them to change it, given that I know there is uncertainty, then we should show uncertainty. That's a kind of an approach which may work in certain contexts, but in a scientific assessment, I think, and that's what Fisher and Davis writes as well, is that the goal is to help people to make decisions that serve their own self-defined best interests. And then honesty is the only policy. We should try to be as honest as possible about uncertainty involved in scientific assessment. If you later on get asked, why didn't you tell us? Well, we had to tell them. There are cases where scientific experts go to court because they did a bad assessment. And in a sense, not communicating uncertainties that there are could be seen as a bad assessment. I don't know if anyone has gone to court for that yet, but let's see. So basically what it means to communicate means that we have to characterize it, we have to identify sources, describe them, and we can assess it qualitatively or quantitatively. But the key is that it's the combined impact on the outcome of the assessment that's important. You know, you have spent all this time describing input in uncertainty in data sources, in parameters, and so on. But it's actually the output, the uncertainty in the output, in what is like decision-relevant elements. That is what we should communicate. And then we can also design messages to improve the way that the decision maker understands it. So communication has all these things into a part. If we just look at an assessment, it could look like this. This is like, it has 5 components. We have a model structure. It's like the embedded theory, mathematical equations, processes, mechanistic thinking, etc., etc. And when we have these, we have parameters. Parameters are fixed values, fixed constants, which basically tune our models so they are a good description of reality. And we can be uncertain about these parameters, right? And then we're trying to predict something that could happen, the state of the world or the system. And that is another type of structure which has certain uncertainties associated to it. And then we have things that we know limit our knowledge, and there are things we don't know, basically. So now I'm going to do a quiz with you, so bring up your pen and paper. Okay, to illustrate what uncertainty is about. You will get 4 questions, there are 2 possible answers, and you're going to say whether you think the answer is true, is A or B, right? I don't see a pen and paper there, but yeah. And then, when you have done that, you're going to also assess how sure you are about your answer. If you have no clue, you put a 5. If you're very certain you're right, you put a 10. And then you can sort of put something in between, depending on how you feel about your answer, okay? The rules are clear? Right. So here are the questions or propositions. You should be quick. Don't Google, don't ask, don't talk to anyone. You're not allowed to talk to anyone. So in this case, if you said 5, you get a score 0, which basically you said, I have no clue. Well, then you don't lose or gain anything. And if you put a 10, you get 25 if you were right, and you get minus 75 if you were wrong. So it's an asymmetric rule here. This is called a proper scoring rule, if anyone is interested. And then you sum up your scores. Yes.
Is red the right color or the wrong?
Yeah, red is right. Okay. So now my question is, now you summed up your score. Is there anyone that got a negative score? Excellent. You know, you are overconfident, which means that you put you said very strongly, this is the answer, and then you were actually wrong. Yeah?
Can I comment on that?
Yes, you can comment on that.
No, because the interesting thing is, if for me it's I have one correct and one incorrect answer and two with 5s that don't count. But the problem is that when you score them both with 7, then you get 16 when you're right,
Yeah.
minus 21 when you're wrong.
Of course. Because we don't want experts who claim things which are wrong, right? It's worse. It's like error type 2 and 1, right? Which one do we believe are worse? And in this case, if someone is saying something with a higher probability than 50% and it turns out to be wrong, it should be a higher punishment for that compared to if they were right.
Okay, I would never claim.
So we want to,
Swedish names, but
yeah. But in this case, you were uncertain, so you should put a 5. What I'm trying to show here is that when we work with expert, for example, there is this this is like the knowledge that an expert has. This is like the knowledge that the expert think she or he has. This is what other people think this expert know. And then we have a dangerous region, right? This is when people think they know something, the expert think they know it, but they actually shouldn't be an expert in that area. I mean, you get quite flattered when you get invited to be an expert somewhere, but so this is like called the area of overconfidence, and this is like when you consult experts in general, one has to be aware of these psychological things occurring when you're working with experts. And I just put it up here because before I said you were overconfident if you had a negative score. But if we go back again to the scoring, did anyone get a positive score? Which one what did you get?
10.
10, and anyone got a higher? Yeah? What?
16.
16? Okay. Anyone? What? 50. All right. Yeah. So you're a good expert to have on board. Yeah. Yeah, exactly. So the idea is that how do we recognize, how do we train ourselves to know when we are uncertain? That's why I'm wearing this button, because I want to sort of feel, I'm happy, I'm proud of being uncertain. I don't feel ashamed by putting a 5 if I am uncertain. It goes against our self, our perception of ourselves as experts. Here's another game. I'm going to play, I don't know what it's called in English, sten, sax, and påse, okay? Let's say that you and me play sten, sax, and påse. We're going to play it 5 times. Can I use this? Yeah. And then we have 0, 1, 2, 3, 4, 5, 6, okay? Can you make a guess of how many times you're going to win over me?
If we're going to play 5 times, I'm not going to win 6 times.
Oh yeah, you're right. We take this away.
Okay, but let's say 2.
Okay, so you're putting a 2 here. Then my question to you, are you sure?
of course, it should be 50-50.
Okay.
So it can be equal.
I'm trying to make you be uncertain. Come on. I didn't say you have to put one number.
No?
No?
Sorry.
You can describe your uncertainty about how many times you will win.
For every time there should be a 50-50 chance
Okay.
between us winning. And I mean, the probability of you winning all is then 0.5 to the power of 5 or something.
Okay. Anyone else? Does anyone else have any idea what is your uncertainty about how many times he will win over me? Okay, so now we're illustrating the fact that we are not used to expressing our uncertainty, right? We're not going to play it now because it takes too long time. Can I get my notebook back?
Yes, of course.
Okay. If I would do this, I would say that, well, with a certain chance it could be here, it could be here, it could be here. I wouldn't say a no, zero probability on any of these outcomes. No. And I could say it's very likely it's here. I put high chances of being in the middle, right? Something like that. But you didn't do that. You just provided this is what I think is going to happen and zero probabilities on all the other things, right? Now, let's take another guinea pig here. You in the back, in the corner, okay? So I'm writing a number here between 0 and 5, okay? If you would express your uncertainty about the number is, what would you write? What would you say? What do you think I have written here?
Instinctively, I think 3. But,
And then my question to you, are you sure?
no.
No, you're not sure, so don't give me a 3. Give me something else. Give me an expression with your uncertainty.
I don't know how to do that.
No. And why don't you know how to do that? Well, what's your background?
I'm a master's student in economic psychology.
Yeah? But you have studied statistics, right?
Yeah.
Yeah? And you have studied probability theory. A little bit. Yeah. I'm coming back to that. So, in this case I put a 4. So you would be 100% wrong if you said 3, but you wouldn't be 100% wrong if you had like given, okay, it could be with equal probability any one of these, right? So the idea here is that these types of problems, they are a bit different. So in this case, following the laws of probability theory and logic, we could set up a model, and if it's just random who wins, we could sort of derive that it's going to be a binomial distribution of with certain probability over all of these, who would win. That's quite common to set up these probabilistic models for that. But in the other case with the paper, it's more difficult, right? Because you don't know me. Maybe I always put 0, right? Or it's like it's more. There is more uncertainty about that one than that one. So basically, one can think of, well, there could be uncertainty there as well. I could cheat, I could have a certain strategy or something. So maybe it could be a binomial or versions of that. So we could have a set of probability distributions for that problem. For the other one, we would have a massive set of distributions because we don't know. Another example here is that when we are talking about uncertainty, a crucial point is that we have to be aware that there are different types or kinds of uncertainty out there. So one is this aleatory uncertainty, randomness. When you have a random event, you don't get exactly, know exactly what's going to happen, but there is a certain probability. You can sort of describe this randomness. It's an inherent property of the system. Then we have, well, we may not know which die it is. There could be uncertainty about the system that makes us, that introduces this lack of knowledge. And the difference between these two, this we call aleatory uncertainty, and then we have epistemic uncertainty, which is to do with knowledge bases. Epistemic uncertainty can be reduced by collecting more information. We can't reduce the probability of getting a 6 by collecting more information, but we can reduce our assessment of this probability, uncertainty in the assessment of this probability by collecting more information. But then there is these other types of uncertainty, the outer side of this egg that I showed you before, things that we don't know that are affecting our trust in our judgments. And what we say in uncertainty theory is that we have epistemic uncertainty, those two to the right, and then we have the aleatory uncertainty, and we should try to separate these two, because if we combine them, we could end up with totally different conclusions than if we treat them separately. So in this case, one could think of that for the model structure, there is epistemic uncertainty. We could have alternative theories. We don't know exactly which of them is true. But we could sort of gain and reduce this uncertainty by studying the problem, studying the causal links and understanding them better. And the parameters, there is epistemic uncertainty about them because they don't vary. They are fixed numbers. They are just sort of things that makes our model work and describe the state of the world. So there's epistemic uncertainty about them. And then the future events, here we have this inherent property of randomness. So whenever we try to simulate the system, you see you get different outcomes every time. There is where we sort of have an uncertainty which is aleatory in a sense. And then when we move into this area where we have things that we know we don't know, it could be like we can describe this, or we can say that we don't know. And for these black swans, it's basically we don't know what we don't know. So there are different types of uncertainty involved, but at the end, what we're going to communicate is like a combination of all these. Whew, that's not easy. So basically the aim is then to evaluate the impact of uncertainty on the output, and we want a combination, and we could also suggest what we should reduce to come up with better answers later on, and then we have to communicate it to different types of audiences. So how should we then express uncertainty? Here are 3 words expressing the likelihood of an event, for example. So what you could do is that these verbal expressions, they're quite useful, it's easy to communicate them and so on. But if we're going to relate it, if we're going to ask people to order them, sometimes they come up with different ordering. If we're going to ask them to sort of compare them to a chance, like a probability, they could come up with totally different positions of them. So what they do is that they try to create these scales which sort of explain, if you have this term, what does it mean in terms of a probability? These scales look different for different organizations. So it can be a bit tricky when you read a report. What do they mean by very likely in this context? So usually they have these scales attached to reports as well. Another thing is that we have these distributions, probability distributions that could describe aleatory uncertainty, but they could also describe epistemic uncertainty, and here is a bit confusing. So in that case, I would say this is aleatory uncertainty, but for the paper, that distribution, a totally uniform, is describing epistemic uncertainty. It's just a unique event. It's like you don't know. This is your uncertainty about what I wrote. But this is uncertainty in a probability chance kind of world, right? Here is another table, by the way, but it's not about the likelihood of an outcome. It's about an assessment over how good is our assessment, which is sometimes called confidence. And the likelihood of an outcome is not the same as confidence. And what I did here was that they decided to have a different terminology just to sort of avoid people making confusions. And one of the things they said is don't put percentages on confidence. Because people is going to think that this is how probably this will happen or something. But this is a statement of how good is our scientific assessment or our conclusion. And you recognize this table, which is used in the climate assessment report. I'm always wondering, like, how do you know where you are? If you have medium agreement and medium evidence, like, how do you know that? And what does this confidence scale, what does it represent? I mean, is it like a clear cut? If we are in high agreement, robust evidence, then we're going to come up with a clear recommendation. If we're down here in low agreement, limited evidence, we are going to say we don't know. But how do you make the distinction where you are? I think it's a lot about negotiations. And to the right, they have an attempt to try to interpret terminology to some kind of statement looking like a probability statement of what it means to be very low in confidence. So coming back to probability, which is one of the things I'm looking at a lot, we basically have these different kinds of uncertainty, and probability can be used for all of these. And that's super confusing. But it's the probability as a measure, but the interpretation of probability is totally different. So for the aleatory uncertainty, we basically say the chance that this will happen, the likelihood that this will happen, has a certain value. For the epistemic uncertainty, we can say our uncertainty about this likelihood, we can describe that using probabilities. And also for the epistemic uncertainty about our judgment or a statement, we could also use probability in a sense, but with some warning. We could say how likely or how strong is our assessment saying roughly what is the probability that this is true. And when we did a quiz, That's what I asked you for. When you said 5, it's 50-50 that I'm right. When you said 100, it's 100% that I'm true. But we can do that when we have like binary outcomes. It's either true or false. But when it's just an assessment and there are infinite number of other possible answers, this doesn't really work. So that's why I put up this warning triangle there. In that case, with Caesar, probability is a likelihood of an outcome, and it's interpreted as a relative frequency. In the middle ground, probability is interpreted as a subjective probability. It's describing our uncertainty about these parameters.
Relative frequency as well, if you observe the system.
Yeah, but in the scientific assessment world, we have to make a distinction between these two. I will come back to that. I mean, it's very easy to show it. I don't have a coin, but let's assume I flip a coin, right? I'm going to flip a coin, and you are uncertain about which side comes up, right? I flip it, I look at it. I have a certain uncertainty about the side of the coin, and you have a certain uncertainty about the side of the coin. So it's subjective. That uncertainty, it depends on what knowledge we have available. It can change over time. And that's why we are treating this uncertainty when we describe it. We have to treat it as something inherent that someone has. It is very awkward for a lot of people with traditions in science to think of probabilities as a subjective probability. But if you look at it, if you look at the philosophy of science behind probability, the use of probabilities to describe epistemic uncertainty, there's been a lot of philosophical discussions about whether it can be seen as a logical probability or if it's subjective. And I think that the common core see that we have to treat it as a subjective probability, otherwise the principles, the philosophy of science doesn't work. But we can come back to that. And the last one here, it's not a statement about, it's not a subjective probability. One can see it as a statement about the state of knowledge, like an epistemic probability. And these describe different types of uncertainty. And the problem here is, how do we separate them and how do we combine them when we're going to deliver our answer? This is not easy. And I'm just going to say something about decision theories. I'm running out of time here, but basically, this slide is just to show you that when we have different ways of describing these sources of uncertainty, these types of uncertainty, the decision theories need to follow along. So if we have if we just say we have only a literal uncertainty, then we can try to sort of maximize the outcome, maximize the expected utility. If we have epistemic uncertainty as well, we can say that we take expectations over this epistemic uncertainty, and then we want to maximize the expected utility, or something where expectations are taking over uncertainty. But as soon as we sort of move out of this, when we have more uncertainty than just these allowing for expectations, then we have to use decision rules which sort of look at lower bounds. It tries to combine upper values with lower values, and you can have, this is a decision theory that sort of, let's say that we are only going to make decisions where we are trying to minimize the risk of missing out on knowledge, called epistemic risk. So basically we're going to take into account all possible values in our parameters that we see in our model, and then we want to make sure that we do some kind of good decision with respect to the outcome risk, given that the epistemic risk is at an acceptable level. So you basically have to treat these different types of uncertainty, you have to distinguish them when you make a decision. And the decision theories here are many of them, and some of them, I would say all these, they work with uncertainty that has been quantified. Then we have decision theories that work with uncertainty where you choose to not quantify some of them, but you can consider them anyway. For example, if you do scenario-based analysis, you don't say how likely a scenario is, but you can say, under this scenario, this will happen. Under this scenario, this will happen. And then you can have decision rules that sort of decide what are good outcomes given these scenarios, without actually putting quantifying uncertainty with respect to a specific scenario and other decision rules. I'm going to come back to this, that uncertainty is something personal. It is something that you and me are. That's why I'm wearing this button, because I want to change your mindset about uncertainty. So someone is uncertain, the experts are uncertain, the risk assessors that are using the experts, they have to make sure that the experts' uncertainty are transferred to be their own uncertainty. And if they don't trust the expert, they shouldn't use them. So there has to be a communication about uncertainty between the experts and the risk assessors, or the scientific experts or whatever. And then there needs to be a transfer from the assessment, the scientific assessments, to the decision makers. So the decision makers should also, so in a sense, be uncertain, right? And as I said again, we have this problem of confidence, and that experts don't want to be uncertain, and have faith. I believe we can improve our ability to express uncertainty. One has seen, for example, that in different disciplines, people who are used to making predictions and they get feedback, they improve their skills in this. But this is usually where you know what's going to happen. It's more about making precise and accurate predictions. But when it comes to uncertainty, as I said, there may be no answer. You may not know if you were right or wrong, because all the events are unique and uncertainty is personal. So, for example, doing these quizzes, doing these challenges where you actually learn to express uncertainty is a way to stimulate that. And if I look, for example, in the when do you learn about uncertainty? When do you learn about probability as a subjective probability that you can use to describe your uncertainty? We don't teach that in schools today. We don't teach it at universities in a way that prepare all the scientific experts for what is to come. If I look in the syllabus for the Swedish high school gymnasium, and I looked at the courses they have, in probability, this is what they teach. And this is the only time probability is mentioned in the syllabus. It's basically that you use probability and statistics to describe distributions, spread in variables. You calculate the probability of events, independent events, and you're looking at how statistical methods and results are used in science and society, and then you're thinking about independent and dependent events and so on. But talking about uncertainty as something that is preparing them to understand the challenges and problems that are out there, it's not happening here at the gymnasium, and it's not happening until after 3 years of studies at university or something. And then it may be too late. So I have some colleagues in England, and they said that they actually introduced probability theory and uncertainty at the course syllabus on a lower level, and now they're seeing that people are more open-minded, they're more prepared to understand these concepts when they get older. So introducing it at an early stage could improve the way we talk about these things and understand them later on in life. Here is a kind of very nice, what do you call it, podcast or something, that David Spiegelhalter did at the last EFSA conference. He's basically saying that there is no single true uncertainty, that it's you who is uncertain, and you should not apologize for being uncertain. Just because you don't know everything doesn't mean you don't know anything, and we should sort of basically reclaim uncertainty. We should be confident about our uncertainty, and it's really nice to go in and listen to this. I put up the tweet here. And they are also working on how to change people's mindset about uncertainty. I'm running out of time here. I'm just going to say something about the European Food Safety Authority. So this is an authority that do the risk assessments about food security or safety in Europe. They work with animal health, they work with chemical mixtures, you know all of them. And they have done lately a lot of work improving on how they treat uncertainty. And I personally think it's really interesting to follow this because they have a systematic approach to it. And they are coming in from a different perspective than maybe people who have been in risk analysis for a very long time. Basically, they looked at how should we improve the way we do scientific assessments. We want to have excellence, we want to be open, we want to be transparent. So they developed something that they called Prometheus, which is the methods for evidence use in scientific assessments. One of the things that are in here is that they consider expert knowledge as a valid source of evidence. They produce various guidances. This is a guidance to do systematic reviews, which basically means that they are embracing the evidence-based concepts into risk assessment. They are doing guidances to work with expert knowledge, elicitation, which is a way to sort of extract probability distributions from the head of experts. I tried to do that with you before, with this one, but you were very reluctant. And that's what they see also. You get all these scientific experts coming in, who's going to take part of a scientific assessment. Some of them have never worked with probabilities before, and suddenly they're going to express a probability about something. Oh, it's such a reluctance. So it's about training. It's about training. It takes a long time. So this is a formal method to sort of take into account all the cognitive and psychological biases that could occur when you work with experts, actually going from having no information to a probability distribution describing their uncertainty about a parameter. And that uncertainty is subjective. And the interpretation of that probability distribution is a subjective probability. Then they did a systematic review. Oh, I can show that. For uncertainty analysis, they reviewed various methods for uncertainty in various organizations all over the world. They sort of basically sat down, what is the purpose of uncertainty analysis? What is the goal? I mean, it's not clear sometimes. So we can know when have we done uncertainty analysis in a proper way. When we have achieved the goals with uncertainty analysis. And then they evaluated the pros and cons of different expressions and methods to do uncertainty analysis. And basically the guidance says what steps in an uncertainty analysis does a specific method do? Does it identify? Does it characterize uncertainty? Does it combine sources to uncertainty on the impact of the output? Or does it do sensitivity analysis or identify source of uncertainty? And so on. I see that Daniel is waving. Then they also, in November, it came a guidance on how to communicate epistemic uncertainty. And I'm just going to show you that this guidance is about communicating epistemic uncertainty. Epistemic uncertainty is not about risk communication. It's about communicating the lack of knowledge. And they also tried to do a systematic review, and they looked for empirical evidence, actual empirical studies testing how people perceive different communication messages. All right. Okay, I guess that's it. I'm done.
Okay.
Running out of time.